Welcome. In this video I'm going to explain what a mode is as a measure of central tendency in statistics. To explain what the mode is, we have a look at the definition. One of the earliest definitions comes from Mr. Carl Pearson, who is a famous statistician, and he wrote the following in 1895. I found it convenient to use the term mode for my English isn't perfect here, so abscissa, corresponding to the ordinate of the maximum frequency. Now, this seems to be a little bit of a technical definition, so a more modern one would be coming from the Encyclopedia of Mathematics from the Eric Weinstein, and there they simply term it the most common value obtained in a set of observations. Now, interestingly enough, the word mode is actually also a French word for fashion and also in Dutch. And fashion is typically what most people would be wearing. So that might be one way to actually remember it. So for the mode, it's the most commonly used value. So if we look at this, we see some orange, green, and red blocks. And to determine which color occurs most often and would therefore be the mode, it's convenient to first stack them on top of each other, like so. And then we can clearly see that orange in this case would be the mode because it has the highest frequency. You can also imagine this now being a bar chart, so simply the tallest bar would then be representing the model category or simply the mode. So to determine the mode, we need to figure out which value or category has the highest frequency. If we're given a few raw scores, then we determine the frequency of each value, so each unique score, and the mode is then simply the value or values with the highest frequency. So if we're given down, left, up, left, right, and up, then down only occurs once. Left actually occurs twice, so I counted this one already. Up actually occurs 3 times, so I counted this one and that one as well. And then we have right, left, that only occurs once. So the highest frequency is actually 3. Now 3 is not the mode, but what it belonged to, and that was up. So from these raw scores, up would be the mode. Then if we have a frequency table, then it's even simpler. We simply look at the category or categories that have the highest frequency. So for example, in this frequency table, the highest frequency is 12. And again, 12 is not the mode, but the category it belongs to, which in this case is East. Last but not least, you might have a binned frequency table or a grouped frequency table or class frequency table with different bin sizes. In that case, it's actually the category or categories with the highest frequency density. Now, most often the bin sizes will be the same, so I haven't talked much about frequency density. In general, it's simply the frequency divided by the bin size. So if these are my bins with frequency 10 for the first one, 12, 16, and 8, then at first you might think, well, 16 is the highest frequency, so 4 but under 8 would be the mode. But 4 but under 8 is also one of the largest categories, so it's a bit unfair to compare them like this. So instead we actually divide the frequency by the bin size. So the bin size is the upper bound minus the lower bound. So for the first one, 2 minus 0 would be 2. And then we get 10 divided by 2. And that would give us 5. 2 but under 4 has a bin size also of 2. So we would divide that one by 2. This one has a bin size of 8 minus 4 equals 4. So we would divide it by 4. And 8 but under 10 has a bin size of 10 minus 8 equals 2, so also divided by 2. So that gives the frequency densities of 5, 6, 4, and 4. Now, as you might notice, 6 is actually the highest, and therefore the model category is actually 2 but under 4. There are actually 2 special situations. The first one is, what if each option actually occurs equally often? So for example, we are given red, red, blue, blue, and green, green. Now, red, blue, and green all occur twice. Then the most common answer would be to say that there is no mode. There are a few exceptions. Some will actually then say that all of them will be the mode, but most will actually say that there is no mode because none of the scores actually has a frequency higher than any of the others. Another question that might come up is what if the highest frequency occurs more often and there are a few that are lower? So for example, we have red, red, blue, green, green, and yellow. So now both red and green both occur twice, and we also have blue and yellow only occurring once. In those cases, most often it will be said that both of them are the mode, red and green. If there are actually two modes, there's a special word for that, and it's determined by model. If there would be three tri-model, etc. Sometimes the term multi-model is used, and if there's only one, sometimes uni-model. Sometimes it can also depend on if there's like a local maximum and minimum. If, for example, you have a graph that looks, for example, like this, so it goes up, down, and then it goes down, down again, and then a little bit up again and down. Then you can have something known as a local mode that would be up here, and a second local mode up here, which is the main mode. But okay, that goes far beyond the scope of this course. Do not average these though, that's a commonly made mistake. So for example, if we would have had numbers, so we would have had 3, 3, 5, 5, 9, and 10, then 3 and 5 are the mode because those occur each twice, and the answer is therefore not 4, because 4 doesn't even occur once, so cannot be the mode at all. So the mode is then really both of them and not an average of them. If you want to find out how to determine the mode with SPSS, RStudio, or Excel, then you can check out my website on peterstatistics.com. If you go there and you click on this one variable, and then you select a nominal variable, and then go for center and dispersion, then you should come up to a page, and if you scroll down, it will mention click here to see how to determine the mode with SPSS, R, or Excel. And then you can click on either SPSS or R or Excel to see a video explaining on how that can actually be done. That was it for this video. I hope you enjoyed it. If so, please like or subscribe, and thank you for watching.